So as Udemo mentioned, the topic is blockchain-based security framework for cyber physical system. As we know that cyber physical systems are very, very complex systems, and these are also known as a class of automated systems, which are basically working as a lifeline of our smart cities. And CPS are transforming the way we interact, monitor, and control.
Or did you get it to go live?
The physical world around us. I think you have to go on mute, Sonatai.
Okay.
You have to mute yourself.
This, I don't need this where I want to be.
Yeah, okay. So the security aspects of these systems are in high demand, as these systems are involved in day-to-day life of people and the national economy. And compromised CPS can harm the day-to-day operations of the people. And CPS systems are very complex in design because very heterogeneous devices are involved in working of CPS systems, and these are more prone to cyber attacks. So in today's talk, I'm going to discuss that how we can introduce blockchain technology, and I am going to share one framework also, which I have decided that I'm going to work on as a future aspect and future research aspect, and which is basically a mechanism to gaining trust when we are sharing a data, when the data is transmitting from CPS to the other devices. So in that, this is the table of content which I have decided.
There we go.
So little bit description about the cyber physical systems, risk evaluated, risk associated with CPS security, how we can introduce blockchain, and what is the framework which I think that we can go ahead with. So I was talking about cyber physical devices, that these can be considered as a systems which integrate sensing, computation, control, and networking into physical objects. As you can see in this slide also, physical sensing is there. We have a strong network through which all the devices are connected, and actuation information also. So in cyber physical system, we can sometimes like integrate, or we can say that IoT is also quite overlapping in that, because the line and the distinction with IoT and CPS is little blurred. So we can say that the advancement of CPS is very fast, including, we can say that electrical power generation and delivery, personalized healthcare, traffic flow management, and emergency response, and as well as in many other areas now just being envisioned. So as you see in this picture, many millions of connected CPS devices will be communicating over the public network and will be providing services to their respective applications. Many applications of CPS, the identity of devices is very, very important, and data generated from these devices from an important part of the overall ecosystem they are integrated in, because when we are giving a cyber capability to the system, the cyber capability is basically working on the data which is collected from the various devices which are connected in the system. If the data which is coming from these devices is not consistent, if the data which is coming from these devices is not secure, then how the system is going to function? Because these kind of systems are known as a backbone of any country's economy, because these are the bigger and complex systems. So in the challenges in the situation, we can say that how basically the actors are gaining the trust in the integrity of identities and the data in an explicit, measurable, and testable way. Because whenever you are receiving a data from any device, how you are going to trust that this is the data which is not hampered, or this data is real data. So this is the main, you can say that the challenge when you are talking about the communication in the cyber physical systems. Now, detection of safety and security deficiencies act as a fundamental building block for creating a security framework for CPS at different various level. We have a physical level, we have another logical level, then we have a different layer with users are interacting. So various levels are having various security and safety deficiencies. So we need to work on a framework which can target all those deficiencies, maybe not all, so most of them. The cyber physical systems, Internet of Things, and digital frameworks are, we can say that, generally the cases of embedded devices, in which the basic requirement is to provide the flexibility to the various applications, because we have devices from the heterogeneous vendors. So we want that flexibility, that as and when we need a device, we can add or we can detach that device, but the system is not going to deviate from the normal operations. That will not affect the working of the complete system. That we know. And also we want the higher adaptability of those devices which are heterogeneous in the nature, which are coming under the cyber physical system, to provide a reliable communication, that whatever data is flowing from these channels, all the data we can trust and we can use for the analysis purposes or for taking the decisions for the other purposes. So that is very, very important. And the existing platforms use the centralized networking. And now, according to me and the research which I did, is suffering from security, scalability, and big data problems. So security and privacy is a significant challenge in cyber physical systems. As you see in this slide, Mirai botnet, a DDoS nightmare, turning Internet of Things into botnet of things. What's happening is DDoS attacks target the cyber physical system resources and the launch from a large number of locally infected devices. So a huge network of CPS devices will be targeted by the DDoS attacks, and these are exploited by the botnets, and whereby the large number of infected devices simultaneously launch DDoS attack. So multiple devices will be compromised, and all are basically targeting a CPS system. Now, in this case, as I mentioned, the Mirai, so you can say that DDoS attack can take many different forms, like black hole, teardrop, while DDoS can take the forms like ping of death, Smurf, and black energy series. So I'm not going in the technical detail of all these attacks. TCP sync flood, which exploits the TCP handshake process by constantly sending requests without responding back to the server, now causing the server to constantly allocate space awaiting for reply. And because of that, that server is not able to respond to the request which is coming from the legitimate clients. And this is basically leading to the buffer overflow condition, where the situation can come in which the CPS system can crash or shut down or deviate from the normal operations. Malware is most of the time used to compromise CPS in order to steal or leak data or harm any device or bypass any control systems, because we know that we need a human-less automated process. So there is no human, but the human is operating the system. So we have to take that when any human is operating a system, how secure this system, which is operated by a human, what kind of security measures are taken care by this system, which is handling the data which is coming from the various devices. So the attacks which we discussed, like Mirai attack was very, very huge attack in 2016, Moodbot attack in 2020, Wild Pressure and Victory Gate attack in 2020. These are very, very large scale. And if I'm not going to mention the ransomware attack, I think I'm going to miss a big name. So ransomware is a malicious software that basically holds and encrypts the CPS data as a ransom. And this is by exploiting the CPS vulnerability. As I told you that there are a number of devices in the CPS system, as you see over here. So we are not sure that how many devices are secure, how many devices are patched with the security, how many devices are basically working as per the requirement of the system. So because of those kind of vulnerabilities, the attacker is able to gain access, and they are targeting oil refineries, they are targeting power grids, they are targeting manufacturing facilities. So we've seen that these are the things, and if we want to see the examples of ransomware, Siski in 2016, WannaCry in 2017, Bad Rabbit in 2017. These are the few names which are the big names in the ransomware attacks. Econs in 2020. So these are the attacks which are planned. So these are the challenges facing by the CPS, like heterogeneity in the device resources, as we discussed. Multiple attack surfaces are there because there can be a physical attack, there can be a cyber attack. So in cyber attack, because we have a heterogeneity in the devices sources, and these devices are having very less power to compute or process. So these kind of problems are there. Scale is very huge because we are talking about millions and billions of small devices, number of sensors which are attached. Everything is centralized. If one thing goes wrong, the complete entire system is going to be shut down. Lack of control over how data is shared, because when we are talking about this scale, we can control, but up to this level, it is difficult to control and manage. So audit facilities also needs to be take care that how we are auditing the things. Also the software stacks and hardware, how you are updating the things. Like if you are using a software, how updated that software is. Is your hardware is capable enough to matching with the current security requirements? Also the poor implementation of security and privacy mechanism. So these are the main challenges which are faced by the cyber physical system. So is there another way forward through which we can implement the security, or through which we can think that, okay, now my data is safe? So I can say that blockchain is the answer. So blockchain, as its name suggests, is a growing chain of blocks. So in this, these blocks are containing the data of various kinds, like that data can be financial transactions related to exchange of assets or linked together using the cryptography. Like in blockchain transaction, these are recorded as like chronologically, and these are forming the immutable chain. And that is basically creating a trust, because in that process, data is verifiable and auditable. Now, the ledger is distributed across all participants in the given network, right? And what is happening in that is, because of this immutability property of blockchain and a clever mix of cryptography and a game theory, everyone in the network agrees with a single copy of blockchain. Now, in addition to like being a system of records where you have everything recorded, you have chain of custody. Basically, we can say that blockchain can also be a platform for smart contracts. Now, we can, if we want to describe a smart contract, so it's an autonomous agent which is stored on the blockchain and is encoded as a part of spatial transaction. Now, which introduces the contract to the blockchain. Now, one can also view as a smart contract as a state machine with its current state, like represented on the blockchain. So any transaction invoking a smart contract stored on the blockchain and will trigger its execution. Now, once it finishes executing, all relevant actors in the network agree on the new state of the smart contract. So whenever there is a change in the state, trigger will happen and all the actors in the network will be notified and will be agreed with the new state of the smart contract. Now, the blockchain is offering a different path towards the greater security, and that is like we can say that we can trust the data which is coming from this chain of custody because this is immutable. And the approach is basically reducing the vulnerabilities and provides a strong encryption, and also more effectively verifies data ownership and also the integrity. So this particular basically giving an advantage that use of distributed ledger, and everybody is agreeing with the new state whenever it's coming. So this particular public key infrastructure model reduces many risks associated with centrally stored data by eliminating the most obvious targets. And that is basically comes where the everybody is trusting with the blockchain, which is the chain which is immutable. Blockchain contains many non-traditional features also, it take advantage of one of the most important cyber security tools, which we all know and which we all agree, that is encryption. So this is the traditional security feature which is used by the blockchain. Also, distributed ledger can utilize the public key infrastructure to secure communication, also to authenticate device. Now, 98% of the IoT device target was unencrypted. A recent study of Palo Alto Network reports this issue and also say that low hanging fruits for the attacker, because when you are not encrypting your data in rest and in transit, you are inviting attackers to come and attack you to access your data. So if we say, so what are the blockchain challenges? We are so happy that, okay, we are going to use blockchain, or we are going to have the facilities of blockchain. So what kind of challenges are there when we talk about the blockchain? So organizations from multinational corporations to governments are basically adopting blockchain security. And basically, this is not simple as updating the existing toolkit, because these are the big smart systems. And as a whole, like, we cannot say that now I'm going to change everything. I'm going to redesign the complete system, entire system using the blockchain. So there are a lot of challenges which are involved in that. So, and the challenges we can say is the data privacy, scalability. So data privacy, we can say that if in the public blockchain, anyone can see and retrieve data in the transaction, right? And that's a concern for businesses. So blockchain is providing security, but we talk about the public blockchain. So anyone can see and retrieve data in the transaction, and concern for businesses that want to closely control what information is publicly available. So that is the main concern of the business when they want to switch to the blockchain. Scalability is also a concern, and it's basically become a constraint when implementing blockchain, because due to block size and the response time. Now we want to work on the security, but then if the latency is much, if the response time is very, very low, high, then it is difficult to implement that. So in this technology, basically every node is storing and processing and maintaining the transactions in a block to ensure security and privacy. Now, as the number of transactions increases, small and medium-sized businesses, I'm talking about that, struggle to accommodate a growing number of transactions in a block. So that's a challenge in terms of scalability. If we talk about the regulations, the organizations and the businesses are still trying to understand that how blockchain structure complexity fits within the evolving data privacy, compliance, and regulatory landscape, because we know that GDPR is basically telling that if you are dealing with the public PII, you have to comply with certain standards. So how these things will be matching with blockchain, that is also a big concern. Interoperability, like some blockchain platforms use a varied ecosystem for their smart contract logic, transaction scheme, models, but weak interoperability, because we know that we have the heterogeneous systems. Now, if there are not interoperable, then what's the point of implementing a new technology for giving security? Because then you have to do a new work for providing the interoperability amongst the devices. So these kind of roadblocks from the developer perspective, also taking a back from the businesses by implementing the blockchain as a security. Now, technology risks are also there, as improper key management and access control. Also, like a blockchain is offering a lot of benefits, as we discussed, the efficiency, the optimization, reduce control, improve security, but then improper key management and access control needs to be taken care, because this is not going to be a traditional way. This is going to be a different way, where the keys will be mapped with the user ownership, and unauthorized access or theft of cryptographic keys may lead to total loss of the data. So we need to take care about the improper key management and access control. Also, unintended forks and chain split attacks which are there. That is also a concern. Inadequate encryption scheme selection and insecure operations are also a risk which is there in the technological area. And the API integration is also the important point, because third parties are always required for API integration, whether it's a private or public blockchain. Now that leads to trust issues, because now you are having a different verticals to trust. You are implementing a new technology, but then also you have to trust on the third party services. So these are the few challenges, but then also I think that if we are going to introduce blockchain as a security for these smart systems, cyber physical system, that will provide a more impact on the security. As you see in this particular diagram, the basic design of blockchain based cyber physical systems is that CPS are basically linked to blockchain ledger, which is distributed amongst the actors in the ecosystem. Then what happen is, the key blockchain features which we discussed, like which are providing efficiency, which are providing the security, will achieve the data stored on the blockchain, and smart contracts executed by the blockchain are trusted amongst the actors which are there. And everybody is going to agree on the new state which is coming after each and every transaction. Now, in this process, CPS devices are trying to send something to client, and client is ready to record the data. So whenever client means, it is representing the actors, those who are working to collect the information. So whenever these actors are ready to collect data from CPS, what kind of steps will be happen, which can be managed and monitored with the help of the blockchain. So basically, if you see in this diagram, I have three components which I have taken. The first component is CPS device. This is the first component, which is able to compute and to communicate, and which is having a cryptographic identity using a asymmetric pair of keys. Now, the second actor which I have is the client, which is representing one of the actors who aims to record the current process of data from the CPS devices with the help of the blockchain. And the third, which I have, is the blockchain system, which stores and execute smart contracts. So this is how my framework works, and I'm going to share these steps also, that how it's going to happen. The scenario is that client wants to record process of data from this device, and taking the help from blockchain, because whenever a data is stored on the client from the CPS, we want to have its security, and we want to have a authentication that, okay, this is the correct one. Now, the first step is the basically client wants to record process data of the cyber physical device on the blockchain. Now, this, what he's doing is he's sending a transaction to the blockchain that requests a nouns. Now, what is a nouns? If I, in brief, if I share the detail about nouns is it to make each request unique, because we want to have a unique request. Like, nobody is able to use that nouns again. This is unique for this request. And it doesn't matter if the attacker gets the older nouns, because that data which is having in that nouns is older and not of any use now. So it is important to have a nouns in every kind of request which we have, because it is making a request unique, so that attacker cannot replay a request in different context. So this is the first point, when client is wants to record the process data from the CPS with the help of the blockchain. So second step is, blockchain is basically processing the transaction and sends a nouns back to the client, that this is a unique particular request. Now, client requests the CPS device to sign its current process. Now, this data and the nouns together. So this particular CPS device is combining the nouns with the data, and it is sending back to the client. Now, if you see this fourth request, the message is built. So signed uses data and nouns. So now this is signed, and we are sending it back to the client. Now, what is happening is, CPS has sent the signed process data and nouns to the client. Now the client is building a transaction for the blockchain, that contains the CPS device ID, the complete transaction. This complete transaction is having the CPS device ID, that from which this particular things will be taken, device ID, signed data, and also it is going to have the nouns as its payload. In this transaction, these things are an action also, it can be mentioned that wants to store it. So these kind of a thing in the fifth step, the client is going to send to the blockchain, and the action is to record the data as I discussed. Also in the sixth point, if we talk as a 6 point also, so in the 6 point, the blockchain executes a smart contract and yeah, to check the authenticity of identity, data, and time with the steps. Like it is going to, as a step, if I want to say, so verify that the signed process data was signed by the claim CPS device. Also check the data was signed with the correct nouns which is generated for the current request. Also, if all checks are true, then save the data against the ID on the blockchain. So this is how the system will work. And with this system, I think we can claim that this is satisfying the security requirement. And this is how we can say that we are providing the security to the devices in the cyber physical system. And we can say that trust is going to be generated. Now, there are a few concerns also with this particular thing, like data authentication and data integration. Like in the proposed system, if I talk, so few points I wanted to mention: data device identification also, non-repudiation also, the secure against the replay attacks also. So how this framework is working, so these are the few challenges on which I'm working. Protection from spoofing attacks, so I'm working on these challenges, and I hope that very soon I'm going to update this particular framework so that this framework is able to answer such challenges which are there when we are going to implement the blockchain. And these are the few references which I've referred for preparing these framework and my slides. And I'm going to thank OWASP again for giving this opportunity to share my experience and my framework with everyone. So with this, I think I have completed on time. And let's see if I can start. Yes. So thank you so much for wonderful participants and the audience for listening me. If you have any questions, I'm available on Slack. And if you want to collaborate with me on such framework and such things, please message me on Slack. I'll be happy to work with you all. Thank you once again. Thank you, Udemo, for nicely introducing me and managing this session. Thank you so much.